an artist's illustration of the asteroid belt dominated by the largest asteroid, Ceres, a dwarf planet. Credit ESAATG Medialab. The asteroid belt may have started out empty, later becoming a cosmic refugee camp taking on leftovers of planetary formation from across the solar system, a new study finds. The main asteroid belt, located between the orbits of Mars and Jupiter, makes up 0.05% the mass of Earth. The asteroids there can range greatly in mass, with the four largest ones, Ceres, Vesta, Pallas and Hygiea, holding more than half the belt's mass. To explain the dramatic range of sizes in the asteroid belt, previous models suggested that the primordial asteroid belt originally possessed a mass equal to at least that of Earth, and that its members had less disparity in mass. The gravitational pulls of the planets later helped whittle down this primordial belt, depleting asteroids of certain sizes more than others. The asteroid belt explained infographic. However, these prior models of asteroid formation raised a question how the belt could have lost more than 99.9% of its mass without losing all of it, said study lead author Sean Raymond, an astronomer at the University of Bordeaux in France. Our approach is the opposite. We asked the question, could the asteroid belt have been born empty? Raymond told Space.com. The answer is yes, effortlessly. Credit Carl Tate, Space.com contributor. The scientists developed computer models of an empty primordial asteroid belt to see whether leftovers from planetary formation could explain the belt's current composition. The inner belt is dominated by dry stipe, or silicaceous, asteroids, which appear to be made of silicate materials and nickel iron and account for about 17% of known asteroids. The outer belt is dominated by water-rich CTYPE, or carbonaceous, asteroids, which consist of clay and stony silicate rocks and make up more than 75% of known asteroids. The researchers found that an empty primordial asteroid belt could explain the mass and compositions of the current members of the asteroid belt. This model suggests that this zone between Mars and Jupiter is a repository of planetary leftovers, a refugee camp housing objects that were kicked out of their homes and left to brave interplanetary space, finally settling onto stable orbits in the asteroid belt, Raymond told Space.com. The strangest asteroids in the solar system. In this new model, the inner belt consists largely of rocky leftovers from the formation of the terrestrial planets, Earth, Mars, Venus and Mercury. In contrast, the outer belt is made up of remnants of the formation of the gas giant planets, such as Jupiter and Saturn. In terms of composition, Jupiter and Saturn grew in a region that was much colder than where the rocky planets grew, Raymond said. Being colder, their cores could incorporate ice and other volatiles. The stipes are about 10% water, whereas the stipes are much drier, having started off in the much hotter terrestrial planet zone. These findings suggest that the asteroid belt is a treasure trove. It must contain relics of the building blocks of all the planets, Raymond said. There must be pieces of terrestrial building blocks out in the asteroid belt, as well as leftovers from building the giant planet's cores. Future research can further test how well the various models of asteroid belt formation match reality. Raymond hopes the team's new concept will help keep people's minds open to potentially drastically different origin stories for the solar system, and for extrasolar planets, too. Raymond, and his colleague Andre Isidoro at the University of Bordeaux detailed their findings online September 13 in the journal Science Advances. Follow Charles Q. Choi on Twitter at Skoy. Follow us at space.com, Facebook and Google.